Okay, let's get started with the absolute basics of electronics. And as we do, let's make sure that we are physically playing with real components every step of the way. And these components are very affordable, so you can buy them yourself, or if you're in the makerspace, just haul them out of the electronics cabinet. And then plug the cabinet in, and when you do, start to imagine that you are connecting to a source of electrons that could flow through the cables into your project. And then imagine those electrons flowing up the copper conductor inside of this yellow insulator up to this switch. And if the switch is off, imagine that your circuit is open, and only when the switch is on or the circuit is closed can those electrons get by the switch to these outlets to flow onward towards your project. Okay, now find the power adapter and take a moment to look at the specs. And let's start with this question: why is this thing called an adapter? What is it adapting? From what to what? Well, look over here, AC/DC. AC is alternating current. Think of the current of electrons sloshing back and forth, coming in and out like the tide. The direction of the current is alternating. And in the United States, we live with an electrical grid where the current is changing directions 60 times a second. And the standard unit for cyclic events is hertz, so 60 hertz. Great, unless we don't live in North America. Then our electricity is going to show up oscillating 50 times a second. But you know what? This adapter can handle that scenario too. It can handle 50 hertz or 60 hertz on the input side. It's also ready for those electrons to show up in their alternating style at a pretty wide range of voltages. And you can think of volts as pressure, the electron charge pushing its way into the circuit. And this adapter accepts a large range of input voltages because in North America you might expect voltage to show up around 120 volts, and in Europe and most of Asia you might expect voltages to be showing up around 230 volts. Anywhere in this range, this adapter is good to go. These are the voltages that can be lethal under the right conditions, so use caution when you're working near this environment. And all that we're going to get near is the act of plugging it in. And in that context, I would just recommend that you not be standing in a bucket of water when you do it. Okay, so high voltage alternating current is going to show up at this visible prong. Then what happens? Well, the adapter is going to adapt the alternating current into DC current. What's DC current? You can think of it as just current in which the electrons only flow in one way. The direction of the current never changes, and the D in DC means direct. And the symbol for direct current is this right here, the line with the dots underneath it. So we're getting direct current out, and we're getting much lower voltages. We're only getting 9 volts out. This is a much safer environment for experimenting with electricity and electronics. And yes, we're getting a maximum of 1 ampere of current on our output side, but we're not going to talk about that much right now because we really need to start playing. The last thing we're going to look at is this diagram down here for the barrel connector. Go ahead and plug in your input side of the adapter to your 120 volt outlet, and then find the barrel connector. Barrel, I think, because it's round like a barrel. Notice how the outside is shiny with a conductive metal surface, and then there's a black plastic insulator, and then down in this shadowy depths is the inside, which is also a conductor, but a different one. Then look back at the specifications for the adapter and look at this diagram. This is showing you the outside and the inside of the barrel connector, and it's telling you that the outside is the negative side of the voltage differential, and the inside is the positive side of the voltage differential. Now that we're working with safe voltages, let's see if it's true. Get out your multimeter, confirm that your red probe is going into the input and your black probe into the common, and turn it on to direct current. See the diagram with the line and the dots measuring volts? Then notice that before you do anything at all, you're going to be picking up something, electrical noise, in the form of millivolts, thousandths of a volt. So don't worry about the flickering numbers. Okay, then take your barrel connector, and with the red probe, the positive probe, put it on the inside, and with the black probe, place it against the outside, completing the circuit. What you're looking for is 9 volts thereabout. I'm getting 9.22 volts. And that's good. That's telling me my adapter is working. Now let's flip it around and start to play. Take the black probe and put that on the inside and the red probe on the outside. What do you imagine you're going to get? When you make contact, you're going to see that you invert the pressure scenario. You end up with a negative voltage. What does negative voltage mean? Is it negative electricity? No, just imagine that the current is now flowing the other way through your measuring device. Very good. One step at a time. Next up, we're going to plug the barrel connector into the barrel connection on the Arduino and start looking for voltages across a slightly more complicated environment. And mostly we're going to learn to look past the daunting complications, maintaining a simple, logical understanding of how the electricity is flowing through our system.